So like I said, today we're going to talk about, well, first of all, before we talk about balancing chemical equations and kind of writing balanced chemical equations, so this kind of next, I don't know, 4 lessons or so, 3 lessons, kind of all deals with the same thing, basically writing out a chemical equation. That's not our job really today, all right? We'll kind of do kind of a rough thing of that, sure, but just basically balancing today, but then eventually we're going to get into writing chemical equations, then balancing them. Okay, and so that's going to be important over the next few days here. Before that, we start with the law of conservation of mass, of course, and so on. Okay, but here we go. So a chemical reaction occurs when one or more substances change to form different substances. Of course, remember we talked about yesterday the 5 clues that indicate a chemical change take place. Yes, so new substances formed, new colors produced, odor, etc., etc. Bubbles. A chemical reaction can be represented with a word equation. For example, now mine didn't really convert too well, but I think yours is okay there. Water plus carbon dioxide equals oxygen and glucose. Okay, so that's a word equation kind of thing. I'm not too concerned about the word equation. I mean, in the big scheme of things, we want to have some formulas here, and we want to have it balanced. Okay, that's ultimately our goal here. So that's fine. It's fine to say that. In a chemical equation, the compounds are represented by their, in a chemical equation, they're represented by, of course, their formulas, right? So by their chemical formula here. And so you have that on the next part there, yes? Okay, which you guys should have there. The subscripts, okay, they are right here. I know this is not as neat as yours, but you're going to have to copy those down there. And I'll just pause this for a second here. So again, if it says the subscript of an L basically indicates it's a liquid, so we would use that for water, for example. Water is a liquid. Ethanol is a liquid. Okay. G is a gas, S is a solid, and AQ basically means that it's in an aqueous solution, so that means it's in a water solution. So for example, the other day when we went to the lab, you took some ionic compounds and you put them into water. We would call that an aqueous solution. Okay. If you want to find the states of the elements, you're going to go to the periodic table. So you guys all have your periodic tables there. For me, over there, yours are a little different than mine, of course, but for me, the solids are in gray letters up there, gray lettering. The 2 liquids are mercury and bromine, which are in blue. And then the red ones are the gases. Yes, the red lettering is the gases. All right. For you, it's going to be a little different, so you're going to have to kind of keep a note of that. You have what? Mostly are green, I think, light green. Those are the solids. They say metallic solids. There's a little legend at the top there that'll tell you each one of those. The kind of aquamarine ones, I guess, the tealy, greeny, kind of bluish ones are probably the solids at room temperature that are non-metals. And then we have the blue ones, which are gases, and then the 2 orange ones, I guess, are the liquids there. Okay, so if you're looking for an element, you're going to go to the periodic table. If you're looking for an ionic compound, well, usually it's a solid. Okay, that can change if you put it into water. So we'll talk about that as we go. Okay. Law of conservation of mass. Again, here, most of these notes are there for you, but basically it just says matter cannot be created or destroyed. You've probably heard that before. Okay, which basically means that if we start with 4 atoms of carbon, we have to end up with 4 atoms of carbon. And that's how we balance chemical equations, of course. You know, if I start with 4 carbons, I have to end up with 4 carbons. All right. That's basically all that says there. Okay, we're not going to act that out. Okay. So, writing balanced chemical equations. To write a balanced chemical equation, okay, start with the chemical equation, or basically what we call a skeleton equation, and add coefficients in front of the products and reactants. Each atom should appear the same number of times on the reactant side as it does the product side. Let's see here. Nope, we've got a lot of stuff here. Let me get rid of this for a second here. Now, here's a balanced chemical equation. How many of each type of atom appears on the reactant side and the product side? So let's do this. I'm just going to rewrite this real quick here, which is what I had from before here, but just give me 1 second just because I know my subscripts didn't convert over and my arrow seemed to be missing here somewhere. I think you have this one already, yes, on the sheet there. Okay. So let's talk about how many of each atom we have here. Okay, so balancing is all about, like I said before, making sure we have the same number of coppers on both sides, silvers and nitrogens and oxygens in that case. Okay, now how many carbon, or sorry, this is copper here. How many coppers do I have on this side? So how many coppers do I have there? Yep, one. So one copper. How many do I have on this side here? Yep, one. Okay, this one's already balanced, right? Okay, so there's one copper there, yes? Okay, are we good so far? How many silvers do I have on this side here? Now, this is where you have to pay attention here a little bit. This 2, this coefficient goes to everything behind it, okay? And I don't even know if I really want to do that. I think I will in this case, but I'm going to show you an easier way to balance that, basically. But how many silvers do I have? Somebody else. No, somebody else. How many silvers are there? That 2 goes to everything behind it. How many silvers do I have? AGs. How many AGs? Quickly, come on. Yep, 2. Okay, so there's 2 AGs here. How many silvers do I have here? 2, right? So 2 silvers. Okay, 2 silvers. How many nitrogens do I have? How many nitrogens do I have? Yeah, Nathan? 2. Okay, so this 2 goes to, remember, everything. 2 nitrogens. And of course, how many nitrogens do I have here? How do I figure that out? Yep. Yeah, so this 2 goes to everything inside the brackets, yes? So that 2 would go to that, all right? So that means I have 2 nitrogens there. So anything in front goes to everything behind it. If it's in brackets with a little subscript, that goes to what's ever in the brackets. Okay, does that make sense? So this 2, like I said, this 2 goes to this and this and this, okay? The 2 goes to here and to here, okay? Kind of thing, because it's inside the brackets. Does that make sense? Okay, we'll get back to that right away. I don't know what your question is. 2 nitrogens, yes. And then how many do I have here? 2 nitrogens, yes. That 2 goes to whatever's in the brackets here. Now, how many oxygens do I have on the left-hand side? Yeah, I gotta be a little, not a little careful, but I don't know, just be aware. Yeah, 6, okay. So look, basically it's saying I have 2 O3s, yes? So if I had 2 O3s, how many oxygens do I have in total? 6. We're going to multiply those 2 numbers together, yes? So I'm going to get 6 O's here. Okay, I don't know how to make an O. That doesn't. Oh, that's not 60. 6 O. Okay. How many oxygens do I have here? Remember, this 2 has to go to this entire thing here. So again, O3 and O3. So 2 times 3 is 6. Yes. So I have 6 O's there. Okay. So is this chemical equation balanced? Yeah, we have the same number of atoms on each side. Okay. Before we move on here, I'll even pause it so in case you have a question. With oxygen on the left-hand side, you know, if it's here and here, then it has to be probably somewhere here over here, of course, but this entire left side has to equal the entire right side. Reactants have to equal the products, okay? Because if we don't, then of course we don't have the same number and you're making new kind of science, okay? Because then they all have to be accounted for, okay? Good for you. It'll be wrong, but good for you, okay? You can try. All right, good. So what are the steps here to writing a balanced chemical equation? Well, it says here, write a skeleton equation, unbalanced chemical equation, okay? Add coefficients in front of the substances so that the number of each atoms on both sides are balanced. Try balancing the atoms with the greatest number first. If it's a polyatomic ion on both sides, balance it as a unit. So balance the entire ion instead of trying to do what we just did, okay? My example here was, for example, I don't know how many times can I say example? I don't know, let's try. In this example here, there's one more, okay? I went, 2 nitrogens, 2 O3s. I would say going forward, we're not going to do, the only purpose I did for that was I just said, hey, let's break it down as simplest as possible. But from here on out, you're not going to do that. Okay, you're going to balance it based on nitrate, NO3. That's what we're going to balance it on. Okay, so we'll show you. Don't worry. If the coefficient is a 1, you do not have to write it, of course. It says balance elements like oxygen last. That's usually a good indication. Check each atom to make sure it's balanced, and also make sure you have the simplest whole number ratio. So for example, let's say you're balancing and you're doing it's all good, and you end up with 2, 4, and then 2, 4 over here. As far as the coefficients, the numbers in front of the compounds, you need to reduce it down. Okay, because that sometimes happens. We just get carried away and things are balancing nicely, and then all of a sudden I look and I'm like, oh, well, I probably didn't need 2 and 4 and 2 and 4. I could have probably used 1, 2, 1, 2, yes? Okay, so just kind of keep that in mind. We would change that to 1, 2, 1, 2. If you don't, okay, we mark it wrong. All right, so there's only one right answer for these, obviously. Okay, I don't give you half marks because I like you, which I would probably give you because I do like you, but it doesn't work that way. Okay, because what's going to happen on a test someday, we're going to fill in maybe a bubble sheet 1, 2, 1, 2, and if you don't have 1, 2, 1, 2, and you have 2, 4, well, then it's wrong, right? So, holy dynamite, that's a lot of. Are you ready for this one? Everyone's like, what the heck? Hey, no, it's fine. I just freaked you out there, didn't I? All right. So listen, you know, I kind of always tell you that you have to be good at ionic compounds. Okay, you have to know how to write the formulas for those, and you did pretty well in the first quiz for the most part. I guess we'll check out this one here and see how the, I gave you a few naming ones just to remember. But basically, like I said, I know you're freaking out. Don't worry, it's fine. Trust me. This is just extra work. You don't even need all this. So again, you just have to be really, really good. And this is probably maybe a bad example to start with. Is there an easier one? No, there's not, eh? Okay. Usually what's going to happen is we're going to give you some, like if you look at your homework here, I don't want you, please don't not start it yet because I want you to do these in a certain way, but you'll see that there's some balancing here, just plain old balancing. Okay, and it looks a little overwhelming right now. What we're doing here is we're going to start with an equation, okay? So this part looks a little maybe scary, but honestly, it's just writing ionic compounds for now, okay? So we can do that, I think. You guys did pretty well in the first quiz, okay, with naming and stuff. So I have no doubt that you can probably do this part, okay? So just relax a little bit here. Just don't worry. I know there's a lot of stuff up there, but it's fine. Look, you probably know how to do this already, okay? So we're just going to start. It says it's a word equation, basically. It says iron 2 nitrate. Go ahead and write the formula for that right underneath iron 2 nitrate. Why don't you guys go ahead and do that now? Iron 2 nitrate, and then we're going to put plus, and then you're going to write out the formula for sodium phosphate. Just leave a little bit of room, okay, for that. And then over here, you're going to write the formula for sodium nitrate, and then you're going to write the formula for iron 2 phosphate. All right? And like I said, that I think we'll probably be okay with. And we'll just stop there, just because I'll give you a little bit of practice here, and we'll just double check it before we go too far here, because I don't want you to write all this stuff down and then be like, oh, I made a little mistake here or something, and now everything's wrong. Let's go ahead and start this here. So iron 2 nitrate and ites are in the top left, right? They're the polyatomic ions. So iron 2, okay, and if you want, if you have this, why don't you do that, right? And then, well, of course, you'd have to know nitrate is NO3 1 minus, yes? And you're going to swap and drop, yes? We're going to need some brackets here, of course, because nitrate is more than one ion. And we're going to put a 2 behind it. So we're going to have Fe NO3 2, yes? Good? Iron 2 nitrate, okay? So sodium is a 1 plus. Phosphate is a 3 minus. 1 comes over and down, 3 comes over, okay? If you're getting these wrong, if you just screwed up on the phosphide nitride thing or whatever, that's not great, but okay. But if you're not getting these, then probably come and see me today, because like this is how we're going to make chemical equations, right? So we need to know how to write formulas, okay? So sodium phosphate should look like that. Sodium is a 1 plus, and nitrate is a 1 minus. So we're going to get that. 1 plus, 1 minus, swap and drop the charges, yes. And then iron 2 phosphate. 2 plus, 3 minus. So the 2 is going to come over and down. I'm going to put 2, and the 3 is going to come over and down, and we're going to put that there, okay? Now, eventually, you're going to do this on your own, okay? That's what we're working towards, but We're not even remotely close to that yet, okay? We're also going to include states eventually. Again, we're not there yet. All we care about is writing this out and then making sure we have the same number of atoms on both sides. Is there any questions about that part so far? Questions? Okay. So I don't know if I can do this. Just bear with me here. I kind of made this. I don't like where this one is. I'm going to try and move it over. Oh, no. This is not going to go. Come on. How do I? Can I? Nope. I know I can move it. That's fine. Okay. So this is not give me a lot of room here. So how do you balance this now? Because obviously there's a lot of stuff going on. Well, I usually say, hey, how do you read a book? Left to right, yes? You got to start somewhere, yes? So start somewhere. You might have to erase some things. That's okay. Okay, pencils have erasers. Pens have erasers now too. They have that technology, okay? So we'll just kind of see how we go here. Now, there is going to be a few, after you do a lot of these, you're going to see, okay, maybe I should start here, or you'll kind of pick up on some little things like, well, that's not the best place to start in this case, but we'll see, right? But I kind of just start left to right. Now, what kind of compound is this? This is not a trick question, okay? I'm just saying. No, not you two. What kind of compound is this? Ionic or molecular? Ionic, thank you. And this is ionic, ionic. Yeah, good. You picked up on the pattern. Okay. So they're all basically based on ions. All right. So when you have what we call, this is called a double replacement reaction. It's ionic compound plus ionic compound gives you ionic compound, ionic compound. Okay. That's what it is. And we'll talk about that coming up and how that all works out and stuff like that. When you have this kind of look to it, it's ionic compound, ionic compound, ionic compound. You balance based on the ions. Okay. So iron, 2 isn't, this is an ion, this is an ion, that's ion, 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 ion. Okay? So we balance based on ions, if I didn't make that clear. So how many Fe's, now this is where you have to be a little careful. How many Fe's do I have here? Okay? How many do I have right there? And that's where I'm going to start because I'm going to work left to right like a book. Okay? So that's the question. How many irons do I have there? What do you think? Not you two. Yes, Cohen. Yes, 1. Okay. Does the 2 belong to the Fe? No, it belongs to this stuff in here, yes? Okay. So I have 1 here. How many irons do I have here? Because that's the only other place I see irons, yes? And that's on the other side of the arrow. The answer is, you're right. So I got to make those the same. How do I make them the same? I put a 3 in front, yes? So I'm going to put a 3 here. Now, bear with me. I don't have a lot of room here because somebody didn't leave enough room. I'll just blame that on me. That 3 is going to go in front. Okay, I just don't have enough room. Is that okay? Okay. Good. Okay. So look, the irons, you've already balanced 1 atom. We only have another 3 to go. Well, ions, right? This is not, they're like, look, this is not bad, right? Now, here becomes the issue. How many nitrates? Like I said before, we're going to try and balance it based on ions, okay? How many NO3s do I have? Now, don't forget, this goes to the iron, and it also goes to here, and this goes to here as well. Yes? So the 3 goes to everything behind it, and the 2 goes to what's ever in the brackets. How many NO3s do I have? Okay, and the answer is what? Yes, 6. Okay. I have, think of it this way, 3 and 2. Okay, I already have 2 NO3s. So NO3 and NO3. That's that part there, yes? Okay, that's the 2 NO3s. Do you agree? Does that make sense? Now I'm going to do that 3 more times. So there's 1, 2 groups, 3 groups. Yes? 3 groups of NO3 twice. Yes? Or 6 altogether. Basically, I'll tell you this. 3 times 2 is 6. How's that? Okay? Make you happier? Okay. Don't worry about it. Okay? So I got 6 NO3s, yes? How many do I have on that side? How many, now careful, how many groups of NO3 do I have? Yep. 1. Okay. This 3 is NO3. That all goes, this is a group. Yes. That's nitrate. That's NO3. I have one group. So I need to put a 6 in the front because I cannot just put it, where am I going to put it? You're not going to put it here, okay? Or, you know, you got to put it in front now. Yes? So, look, iron's balanced, nitrate's balanced, yes? So we're going to move on to sodium. How many sodiums do I have there? This is not a trick question. Okay? Somebody else answer for a change. Anyone? Tie? 3. Look, 3, yes? So we got 3 here. How many do I have here? How many? 6. 6 goes to everything behind it, yes? How am I going to get 6 here? They already got 3. How do I get the 6? Put a what? Remember, I can only put numbers in front now. 2. Last time I checked, 2 times 3 is 6, yes? 2 Na3s. Na3 and Na3 is 6, right? How many PO4s do I have here? That's phosphate. How many PO4s are there? There. How many times can I say that now? Sure, Nathan. Yeah, there's 2, right? So this goes to this, right? And this goes to that. There's 2 PO4s. How many PO4s do I have over here? Down. 2. PO4s are done already. I didn't even have to do anything about it, right? They're already balanced. Okay. So, do we have the same number of atoms on both sides now? Yeah, I think so, right? And that's not that bad, is it? Okay, you just got to take it slow. You got to go one kind of section at a time, yes? This works really well for ionic compounds because you're going to balance it based on ions. Sometimes that's not going to happen. Okay, like our next example, when you take a look at that, you're going to see it's kind of different, right? But look, again, I'll do it in red here. 3 irons. 3 irons, yes? You can go back through and double check. 3 and 2 is 6 nitrates. 6 nitrates, yes? Okay. 6 NAs, 2 times 3. 2 times 3, 6 NAs. 6 NAs, right? 2 PO4s and 2 PO4s. Okay? Good? Okay. Now, obviously, this is the first, sounds like it's the first time you've ever seen this, so it's going to take a little bit of practice, right? That's why homework's going to be important. We're probably going to make some mistakes. It's okay. We'll fix them. We'll give you more practice, okay? I promise you. But this is kind of important, okay? If you have any aspirations of doing anything Chem 20, before you even don't even think about Chem 30. But if you want to do anything with chemistry, you have to, balancing chemical equations is like the thing. You know, that's what you probably do the most of. So you have to be able to kind of figure that stuff out, okay? All right. Now, let's take a look at the next one here, and don't even look here. I'm going to rewrite this because I don't really like how they wrote this here. See, what the? Let's try that again here. I suppose this is going to be, see, I don't understand this. How does that happen? Like, I don't understand. Like, it was working just fine. Now I have to do this again. Oh, wait, whoa. Ah, this is going to be on YouTube now. Watch this. How do I get out of here now? Oh, there we go. Okay. Oh, no. No. Okay. We're back. All right. So I think they put O2 and CH4. I think that's how they wrote it in yours too, right? Most of the time I'd say, and it's up to you, you know what, let's do this. I don't like that. I'm actually going to have to leave a little bit more room, aren't I? Let's try that again here. CH4 and O2 gives me CO2 and H2O. Let's just do it this way here. this is something we would call a combustion reaction. Okay, we'll learn that. You guys talked about combustion reactions before? Yeah, okay. Yeah, no. I'm getting this. Combustion reaction, so that's when we burn something. Anytime you burn something, you need a little bit of oxygen to go with it so we can burn it, yes? You know, if you're talking about your car, it takes gasoline, that's the fuel, and then it needs some oxygen. It goes through the air filter, makes sure it's nice and clean, enters the combustion chamber, and explodes, yes? All right, now, what kind of compounds do we have here in this case? So we have CH4. What kind of compound is that, ionic or molecular? Come on, we got to know this. Yep. Oh. Molecular, that's the other option. Two nonmetals, yes. Carbon tetrahydride, yes. Oxygen, well, again, probably nonmetals, right? And we get some carbon dioxide, molecular, water, molecular, yes. So we're not going to be balancing ions in this case because there is none, right? There's no like sodium ions, phosphate ions. This is like CH4, just a bunch of atoms. So we have to go atom by atom here. Okay, we don't have a choice. So again, we just kind of do what I did last time. I always just start left to right. Let's start with, and don't start with oxygen. Okay, that's probably I would say that, do not, and that says it in the notes there. Don't start with oxygen. That's probably your last job, okay? How many C's do I have here? 1, yes? All right. How many C's do I have here? 1. You're done. Let's go home. No, I'm just kidding. All right. How many H's do I have here? Yeah, 4. How many H's do I have here? How do I make it 4? Put a 2 in front. 2 times 2 is 4, last time I checked. But you also have to know multiplication table, eh? That helps. Or nowadays you can use a calculator, right? All right, now, so C's are done, H's are done. Look at us go, eh? Maybe we should have started with this one. It didn't freak you out, right? How many O's? I'm just gonna pause for a second. I don't want you to yell it out or anything. How many O's? Well, how many O's do I have here, first of all? Okay, that's not a trick question, eh? How many O's do I have on that side? Now, just don't say anything. Just let people think about this. How many O's do I have on the product side, on the right side of the arrow? How many O's do I have on the right-hand side? And don't forget, we have to include all the O's, yes? This quite often happens in a combustion reaction because we quite often get carbon dioxide and water. That's going to be your reactions for this year. Next year we'll ramp it up a bit. How many O's do I have on the right-hand side? Ooh, you have 4. Okay, there is 2 here, yes, and then there is another 2 there. Yeah, that's 4. So how many do I put on the left-hand side here? What do I got to do? I only got 2 here, so what I'm going to do here? Put a 2 there. There you go. You're done. Okay. Good. Questions? Yeah. Because that's not how oxygen comes. Oxygen comes in 2s. Yeah, these are the compounds. These are the elements that you start with, right? You can't just start making up new stuff. Okay. Good. Any questions? Okay. I'm going to double check this one. I just want to double check before we get to the homework part to see if there's any, if I have to do that example yet or if I can wait. I think I can wait, but I don't want to confuse you too much. All right, now, don't look. Okay, and now I would usually get you to do this part here, but again, there's lots to this. So here's another word equation. Go ahead and let's start that at least, I guess. I guess I should pause this. I don't think you need to. In this case here, okay, well, first of all, we got to kind of take our word equation here. We got to transfer it into actual formulas, elements, whatever the case might be, yes? So sodium chloride, of course, that's an ionic compound. Hopefully we recognize that. Sodium chloride looks like Na1 plus and Cl1 minus. So we'd probably write that down here, sodium chloride. And usually what we're going to do eventually is we're going to write down states, but we're not going to worry about that yet. I think it did say that in the, I think in the notes, like ionic compounds are usually solids, but again, we probably don't know that until after the 5 reaction types that we're going to look at. Okay, so that's fine. These are elements, though. We could definitely look these ones up because they're on your periodic table, yes? So sodium, what does sodium look like? Well, that's an Na, yes? And by the way, I am going to put solid there because you can just look that up on the periodic table. Again, this is not going to be a big deal for today. I'm not too concerned about it because we're going to talk about, this is actually something called a decomposition reaction. And we're going to look at that when the time comes in the next couple days here, okay? And then chlorine. Now, notice it says chlorine, okay? Now, when I think about chlorine, this is what it says, that this down here. Remember this Hofbrinkel thing here? Or my thing was, I have no brighter, clever friends, people stupid, yes? Okay? So when we talk about some, notice how, for example, going back to this one, why does oxygen come in twos? Well, why does it come in twos? Because it's more stable, yes? They help each other share electrons to become octet full, yes? So when you're walking down the street, you're probably not going to see O, you're going to see O2, you're going to see them connected together, O2. Okay, they're helping each other become more stable. So oxygen comes into nitrogen, chlorine, bromine, iodine. Okay, all those things come in twos. I have no brighter, clever friends. Okay, all come in twos. If we're doing something with phosphorus elements, we'd probably want P4. Okay, sulfur S8. Okay, but like I said, we're kind of jumping a little bit ahead, but we do have to remember that when we're writing these equations. So when it says, that's fine. If it says sodium, you have to remember this, Hofbrinkel. Is it one of these elements? Like if it's hydrogen, you probably should put hydrogen H2, okay? If it's nitrogen, again, it should be N2. The problem is there's a difference between N2 and N3 minus, yes? That's part of an ionic compound, so we have to just be a little bit aware of that, okay? For our purposes, this is chlorine, okay? So chlorine looks like this. Now, it would not say this, but I'm just saying, okay, and there's a difference here, and this is actually not too hard to remember. Look, chlorine is Cl2. Chloride would be something entirely different. Yes, that's Cl1 minus. It says chlorine, so we're going to put Cl2. Bromine, Br2, iodine, I2, hydrogen, H2, nitrogen, N2, okay? All right, now we got that figured out. We just got to balance it. How many NAs do I have here? It's not a trick question. How many? 1. How many do I have here? 1. We're good, yes? How many Cls do I have here? 1. How many do I have over there? Okay, how do I fix it? I put a 2 here, yes? Okay, you can't put it anywhere else. Once you make these compounds and these elements, you got to put the coefficients in the front. They're called coefficients, okay, by the way. So now what, though? I got to go back and fix the Na, don't I? So don't forget, that might be the case in some cases. Now I have 2 Nas. I better put a 2 there as well now, okay? So, and then again, at the end, just double check and make sure you got all the atoms there, right, that you account for. See, it's not that bad, is it? Okay. All right. Good. Any questions, anyone? Okay. We're going to pick out a few together here. Let's, this is what I'm going to do here. Let's take a look here. So I know you got some homework to do here. I think we are going to do this one, even though, yeah, we are going to do this. You'll have still lots of practice. Let's look at 1A. Okay. You have what? Nickel and bromine gives you nickel, bromide, and that's a 3, obviously, yes. Solid. Okay. Okay, that's the first one. No, it's a 1A. Okay. Now remember, you have to balance both, obviously, yes. But when you look at this, okay, and again, this will come with practice. All right, so don't freak out yet. But like when you look at this, pretty quickly, I don't know about you, but can you tell that, first of all, I guess when I look at this, I have an element plus element, yeah, to give me compound, yes. So I'm not going to balance it based on ions because I don't have ions, ionic compound, ionic compound, ionic compound, ionic compound, right? or anything like that. So I basically just have to go element by element here. Nickel is good, yes, and nickel's good, yeah? When you get these kind of questions, so you get Br2 on one side, you get Br3 on the other side, notice, yes? So when you get these kinds of questions, you're going to see these quite often because these happen a lot, okay? When you see that, how are you going to fix that? So how do you get the same number on, because Br is the issue here, isn't it? Right? I mean, nickel's good, it's balanced already. Pretty soon it's not going to be, but right now it is. So I look at the BRs and I'm like, well, Br2, Br3, we have a term for that in math, yes? 2 and 3. So what are you going to find? Yeah. Yeah, so the lowest common multiple. Or basically, look, if it's 2 and 3, we want to make it 6 on both sides, yes? Is the lowest common multiple. Just make sure it's the lowest one, because if you picked not the lowest one, for example, if you had, I'm just throwing this out here, let's say 4 and 8, and you decide, well, I'm going to multiply the two to get 32, that's not the lowest common multiple, right? So you can do that, but when you're done, you're going to have way too much of everything, and you're going to have to go back and reduce everything. You know, that goes back to the 2-4-2-4 thing. That's what's going to happen. You're going to end up having to go back and reduce it all. But it still works. You could do that, but it's not great, okay? So in this case here, I'm going to make, like you said, 6 on both sides. So 3 times 2 is 6. And remember, 2 times 3 is 6, yes? So I'm going to put those numbers in front to make sure that I got 6 on both sides. Is that good? Okay. Look, if you understand that, we're golden, okay? And then the only thing I got to fix now is what? Yeah. 2 what? Nickel. Yeah. Nickel. That's okay. 2 in front of the nickel, yeah? And we're done. Okay. So that happens sometimes. All right. Now let's take a look at. I wanted to do another one here. Which one was it here? Oh, you know what? I'm gonna. Okay. Yeah. You know what? I'm just gonna say this about J. So let's go down to J here. Oops. That's not J. Let's try this again here. L, aluminum carbonate. And I'm just going to skip the states here real quick. Solid. Yeah. So this is J. Okay. And again, that's fine. That's all good. So you kind of have to first of all decide, how am I going to attack this? How am I going to balance it? Am I going to go based on each atom by itself, or do I want to try and do some ion stuff, like group some stuff together, right? This one, I'd say, well, this is of course an ionic compound, right? So aluminum carbonate, ionic compound. This is an ionic compound, yes? So this is not, right? So the reason I tell you this is because it only works if you're going to group stuff together like ionic compound, if you're going to balance based on groups, ions, it only works if you have all ionic compounds. Or at least, for that matter, maybe an element, an ionic compound, it might still work. That's a single replacement reaction. This is not. We got a mixture of ionic, and molecular. That's not going to work here. So your only option for this is going to be each element at a time. What you have to remember is, most you're like, well, that's Al2, yes? That's 2 aluminums. And then you're going to go here and then you say, that's 2 aluminums. I'm on a roll, right? Look at me go. How many carbons do you have here? And then I think we'll maybe just do this one. How many carbons do you have? This is usually a tough one. How many? Nope. 3. Okay. So remember, the 3 goes to each thing inside of here. Or you could say 3. You could say 3 carbonates. The issue is you don't have CO3 on this side. Yes. You don't have the carbonate ion over here. So that's why you can't balance it based on ions, because you don't have the same thing on the other side. That's the issue. Okay. So 3 carbons. So how many carbons do I have here? That's the only other place I have carbons. How many are there right now? 1. So how I fixed it? You put a 3 there, yeah? Like so, right? Now, this one usually confuses students. How many O's do I have there? How many O's altogether? 9. 3 times 3, 9. O3, O3, and O3, yes? So 3, 6, 9 altogether, yeah? Okay. 9. How many do I have here? How many do I have here? 6. 3 carbons, 3 O2s, yes? 6 and 3 is 9, right? I got 9 here. You got 9 O's here. You got 9 O's here. So that's balanced already as well, yes? Okay. Does that make sense? Don't forget, you got to add up the right-hand side, right? It's all the O's there, not just one of them. Okay, yep. Nothing. Yeah, so on your sheet, there's little lines there, right? Or little blanks. I would just say, you know what, let's just leave it blank, okay? Now, if you're gonna do a test and it says you need to write the coefficients, then you're gonna put a 1 there, yes? And you can still do that, but when we write chemical equations, like when I write this out, that's a chemical equation. I don't put 1s in front because they're just implied, right? But, you know, I know some people like to fill in the blanks, you know, and that's fine. You can put a 1 there. I'm just saying that usually if we wrote this out, which is the ultimate goal here, is once we start writing these out, we're not going to go back and put 1s in our notes, right? Like the last 2 questions you'll notice, that's where you got to write them out, and you're not going to put a 1 in front of there, okay? It looks silly, all right? Let's see, do we want to do one more? There is one more that I wanted to do, but I don't know if I have an example of that here today. Oh yeah, I do. Yeah, that's not going to work. Okay. Yeah, no, I think that's probably good. I think I'm just going to let you go ahead. And I'm going to tell you, like, looking at some of these, you know, don't get too frustrated because I would say some are pretty straightforward, I think. There's definitely going to be some challenging ones here too, especially if this is your first time, which seems to be most of you. So there's going to be some trickier ones and there's going to be some easier ones. So, you know, if you're really struggling with one, I would suggest move on to the next one. You know, if it really doesn't work out, just take a break from that and move on, you know, and then go back and try it again later. And if you still can't get it, we'll figure it out tomorrow. I hope there's questions tomorrow. There should be questions tomorrow. I'd be surprised if you got them all right. That's not going to happen, okay? And that's okay. This is grade 10 now. Welcome. 2 and 3, okay? At the bottom here. I'm not going to do those, but I'm just going to say this to you, like those 2 are exactly what we did on the very first example that you were like freaked out about. It's the exact same thing, okay? So the first thing you got to do is just relax, okay? And secondly, you just got to write the compounds out. Don't worry about states, just write them out. Write out the compounds and then go back and balance it. The only difference is it's in words, and I'm not giving you the formulas for those, but you know the formulas for ionic compounds. You just go back and write those in and then go ahead and balance it. That's all, okay? But I'll give you a try, and if, like I said, if you're really struggling and you're like, I really want to know how to do this, or I can't get this one, I'm around at lunch today. I'm around in the morning. You know, if you really can't wait to class, that's fine.